Hey, don't forget life's math and history, and we are going to take a look at continuous compound interest. So, what we're going to try and do is solve a problem and see what kind of problem this is. So, a small country grows its population exponentially if it continuously compounds and the rate is 2.8% each year. What is the country's population in 8 years? And currently, the country has 1,845 people, or that many citizens. But the problem is, we know what formulas there are, but we don't know how to execute the problem. So recently, we've learned about these two problems right over here. Y equals A parentheses 1 plus rate parentheses by time. And this one, in case it compounds more than once, y equals A parentheses 1 plus rate divided by number of times the time, multiplied by the number of times. But the crazy thing is, this formula below calculates how many times it has compounded in a given amount of time. For example, imagine if it was like semi-annually for a bank, it would have compounded itself 2 times within just 1 year. But the problem is, this problem right over here says that it compounds continuously, not just 1 year in 8 years. So there's a little bit of confusion. So right over here, we're going to try to learn a new formula and help us understand how are we going to calculate and get this problem done. And how are we going to calculate compound interest that's continuously happening for on and on and on. So we are going to look at a pattern. And yeah, here is the pattern. So last video, we've been doing the definitions of like how many times something has compound. But we've also been learning about this formula on the bottom. What this chart shows is if you were to compound as many times as shown per year, what would happen? So annually, since it's just one time, it's just one. You would have earned $2 if you invested $1 into the bank. If you did semi-annually, meaning that it compounds twice a year and invest $1, you do the math for compound interest and you get $2.07. No, $2.70. Funny. For quarterly, when you do that, you do the formula, invest $1, $2.71. Monthly, when you do that, you compound by 12 in just 1 year. And you get this crazy decimal 2.718. So what it's trying to say is there's two things. One, the more you compound by itself in a same amount of time, when you compound annually versus you compound 52 times a year, the more you compound, the more decimals you're going to get, and a little bit more money that you would expect. So if I were you, you can't really compound to get decimals, because banks don't count decimals, unless it's just hundreds, like cents. I would want it to compound quarterly, then annually, so I get a few extra cents. But not only that, there is a little pattern. Every time you go down the list, say 1, 2, 4, 12, 52, you're basically adding another decimal to the sequence. The sequence is 2, 2.7, 2.71, 2.718, 2.7182, and so on. So, if we compound more, the number of decimals, the number of digits is going to increase. If we take a look at the next one, where we say after hourly, we also show up every minute. And yeah, this is really, really messy, because the bottom, I'll show later. So every minute, when you do the math, this is how much you would be able to get when you invest $1. For every second, it's going to get even more. And if you do that every second for a year, you get $2, 7.828182 as like a cash value. Therefore, there is something very, very cool about this. Therefore, we can say that there's some kind of letter E representing it. And it's going to equal 2.718288182. And not only that, I tried to calculate all the digits and write them down on a piece of paper. But since there are so many digits, I lost track and wrote the wrong numbers. And that's why I crossed it out. So, the E right here is called Euler's number. And it was made by a mathematician named Jacob Bernoulli, even though it was named for Leonhard Euler. Those are two mathematicians, but Jacob Bernoulli actually founded it. E is very useful because it's helpful when you want to calculate. If something was continuously compounding for over a year, then what would it be worth after that time has passed? Many banks would use the letter E and also use a special formula to calculate this. And even though this problem right over here does not relate to money, it has the same kind of format and also the same kind of function. Yeah, when you do Euler's number, it's not just a set number of digits. Just like pi with 3.14159, Euler's number is irrational, meaning you can count as many digits as you can. It goes on forever! So, let's start the problem. If it's continuously compounding, there is a formula we can use. The formula is actually easier than the last ones we learned in the last few videos. So, the formula is going to be your Y, or your total number of money or value, is going to equal your principal, represent the letter P. That is going to be how much money you put in right now. Then you have your letter E. Your letter E represents 2.718288182, which you won't be required to memorize because you can use a calculator. Then that E is going to be the exponent of your rate multiplied by your time in years. Remember, this formula right here is supposed to calculate continuous compound over usually more than 1 year. But if you try to use it with just this problem, you would spend hours and hours trying to do this infinitely, which you can't. And it's also a lot more complicated. But you can solve this in just 3 easy steps. Step 1, get a calculator and turn it on. According to the problem, we can say that the rate is 2.8% each year. The country currently has 1,845 citizens, and we're trying to look at the population in 8 years. So going to the problem, the total number of citizens is going to equal 1,845, because that's our principal, the amount we started with. Then we have to use parentheses, E as in this value right over here, times 2.8% is going to be 0.028. Then we multiply that by 8. So step 2 is done because we gotta write out what the math is. And step 3 is actually using the calculator. Using order of operations, we have to use the letter E first. So hit clear in case any other problem was done before this one. You do the second ln, and that will get you e to the exponent. You do 0.028, multiply that by 8, because that is going to be the rate times the time in years. You get this. But what we don't want to do is clear it and manually try to do math with the principal. The reason why is there are many decimals into this number. Instead, we're going to go ahead and multiply by 1,845 citizens. And we are going to get this number right here. But it's not like we can slice the citizens in half. That would be weird. So even though there's a decimal, we're going to keep it as a whole number and round it down. So the total number of citizens, y, is going to equal 2308.22. But we're going to get rid of the decimal because this is how many citizens live in that new small country right over here. If you're using continuous compound interest and Euler's number and you get an answer of $222.5678, what banks would do is they wouldn't round it because rounding it would create another cent, which you can't do. Instead, they'll just focus on what the calculator immediately says, and the final answer would be the first digits until the decimal, and then the first 2 digits. The bank would never round it, because that would be breaking the bank, and that would also be breaking mathematics. So yeah, I hope this video has helped you understand continuous compound interest. Thank you for watching Taoping Airlines Math Industry. Like and subscribe!